So you go to this website here, and you click around until you find where to install it, and you go to here and you install it for Windows, and then it will download, and somehow now it's, can't see it, but it is there. So it's there anyway. So I downloaded it because I thought it might take a long time to download it. So it's there, and then you have this, just like any other installation. You just double click on it, click run, whatever language you want, next, 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 and that's all, and it's over. It's all just like any other program. I'm not going to overwrite the one that's there. Well, I guess I could. It won't hurt, I guess. No, it shouldn't make any difference. You just do this. If you have a 64-bit computer, I guess you use that. If it's not Windows, you use obviously you use the Mac one. That's it. Then once it's installed, you can open it up and you can do things on it. So, for example, let's open up our code school. I think there's a more famous site called Code Academy, which has a lot of stuff, but this has a reasonably good R course, so that's why I chose that one. And sign in. Okay, so we have the R course there. Anyway, so this is not quite finished installing. Bigger than I thought. And every time there's a new R version, you can download the new one, and the old one will stay on your computer. Whether you, I don't know if that's what you want, but it will, by default, it will stay on your computer. So anyway, here's the program then. It's just R, and I'll choose this one. And it's just like any other R. Okay, and by the way, you can go to here and change the preferences for the way it looks. Okay? So, of course, then you can do anything that you can do on R, like 5 plus 9. Yeah, like that. It's just R. Okay? Any questions about that? By the way, there's something called R Studio, which is a kind of nicer way to interact with R than this interface is. So if you want to download that, you can also download that. It's called R Studio. It's one word. So, but I won't do that, at least not for now. Okay, how about the quiz? Do you see it on your website yet? There, do everyone see matrices in R? Not yet? How about if you refresh the screen? Not yet? I want to make sure it's available. Yeah, it should be available. Oh. No. It's available. Okay, maybe it's not available until 10:45. Display after 10:45, okay. So in about a minute, or less than a minute, about 25 seconds, if you refresh your screen, it should be available. So why don't we finish that first, and then we'll go on to the rest of the class. And I think I asked you to go up to chapter 4 last time, right? which was about summary statistics. So let's just quickly review this and open up your R on your computer as well. So open this here so you can try some of it actually within R. Let's just go review a little bit of this. Just maybe I can make some things clear. Okay, so the first thing we talk about is the mean, and what are they doing here? They're creating what kind of thing here? What do we call this kind of thing? Call it a vector. Creating a vector. And the name of this vector is? What? Limbs, right? And how many elements does it have in it? 8. Good. Okay. So let's copy that. Can you get that also on your computer? On your website? So let's copy that and put that in R and create our own vector, limbs. And then type out the word limbs and see what result you get. What do you get? What will I get? I'll just get that I'll get a vector that has those 8 elements in it, right? If I do that, I get that. How about if I want to add 1 to each of those numbers? How could I do that? How about if I want to add 1 to each of those numbers? I could type limbs plus 1, right? And I get that. Okay, does that change limbs, by the way? If I type limbs, will it be different now? No, it's going to be the same, right? How about if I wanted if I wanted limbs to be changed so that it was each element was incremented by 1? How could I do that? I would do what? Type limbs equals, this is the weirdest course actually. I come up with these really weird names like limbs. But anyway, limbs plus 1, right? And now I'm redefining limbs. That equal sign you can have this kind of, or you can have an equal sign, doesn't matter. So now limbs looks like what? That. Okay, so we redefined limbs. Okay, so they did that. Now, what's this do here? Gets the mean of that vector, right? If I do that, I get the mean of those numbers, which apparently is 4.5, right? Okay, so now, how about if I do this? What's this going to do? Bar plot of limbs. I'm going to make a plot. So let's try that. Bar plot of limbs. I'm going to make a plot. So let's look at that plot. Okay, so it does that. How do we determine the heights of these bars? Where do the heights of these bars come from? From the vector, right? From the values of the numbers in limbs, right? So therefore there are how many bars here? 8, right? 1 for each element in limbs, right? Okay. So now what they do is, what does this function do? I think you read it, I guess there's no necessary way to how to pronounce it, but I think it's AB line. I don't know what it's called. But so what does AB line do? it allows you to take your current graph, whatever your current graph is, and draw a line in it. So if I wanted to draw a line of height 2 on my current graph, I could use this to do that. So the way you would do that is you go here, I have my current graph, so that's the one where this is going to be affected. That's what's going to be affected. So I just type AB line. So it's a kind of a weird function, but this is the way it works. H equals, let's say 2. Okay, if I do that, you can try that, or I'll try that. And what happened? It allows you to draw a line on your graph. And if you wanted to draw a vertical line, what do you think you would do? Because this is a horizontal line. If you wanted to draw a vertical line, what do you think you would do? It's V. You'd use V, I think. Let's make sure. Let's try AB equals 2. Did it work? Yeah. Okay, everyone get that? Now try this. I forget how this works actually, but I think it's like this. AB, I think you do, I'm not sure. Let's try this. I don't remember how to do it. But I wonder if this is right. No. I don't remember how to do it. This probably won't work. 2x. No. Isn't like that. Okay, let's get some help on limb. On AB line. Okay, here. This is the way it works usually. You can use this H argument or this V argument, but the standard way, I believe, is this. So we put in an A and a B. So what does that do? What are the A and the B? So how do we figure out what this is supposed to do? We want to understand what the arguments are. What's the meaning for A and B? And where do we find that information? May not be easy to understand, but where do we find it? Up in this section of the help. So what is A and B? In this case, not too hard to figure it out, to understand what it means. What does it say? A, comma, B are the intercept and the slope. Okay, so what I want to do now, let's try this. So type this, and put in, like, let's say intercept is 1, comma, 2. So first, any guesses what this is going to do? So I'm putting in A and B as 1 and 2, where A is the intercept and 2 is the slope. So any guess what this is going to do? Before we do it, any guesses? So A is supposed to be the intercept and B is the slope. So it's going to draw a line that has slope 2 and intercept 1, I hope. Let's see if it did. Okay, so it did, basically, do that. Okay, so you can do this kind of stuff with this AB line. And it only affects the current graph that you have. Okay, now suppose I want to compare all these heights to the mean height for all of the data. I want to visually compare them. So in other words, I want to put a line in there at the mean height. So I could say, one way to do it would be, I already calculated the mean height, so I could just use that number, 4.5, and say H equals 4.5. But there's another way to do it, which is to simultaneously calculate the height, the mean. So you do this. Mean of limbs, like that. Okay, everyone understand that? And I need an extra parenthesis here. Everyone understand this idea? So if we do it, now I get another line. I don't know which is which, but maybe this is it, 4.5. So this is like, gives me the average of all these bars. Okay? Any questions about that? Okay. Now there's another quantity that we learned about called the median for data. And how do you get the median of this data? I mean, if you were going to describe how to do it, not use this function. What was the way that they said to do it in the book? They said you line these up in order first, you reorder them. So what's the first one? 2 should come first because it's the smallest one and so on. And then you find the middle value. Now in case that there's an even number, we have to do a little trick. Right? We have to punt, as they say in football, American football. But anyway, that's what you do. So you can do that here. Where is it? Median. In fact, let's just do this instead. So what's this going to do? It's going to calculate the median and put a line in there, right? So let's just do that all at once. I forget how to change the color of this line, but it would be nice to do that, wouldn't it? So the median is where? Is that it? 5? Yeah, I guess the median is 5. Is that true? Maybe. No, that's not true. What is the median? Let's type out the median. Five. Huh? Okay, maybe it is 5. Okay? Oh, because, yeah. Okay, I added some number to that. Yeah, that's right. Okay, so the median is 5. This is my new limbs, right? I changed my data. I don't know if you changed yours, but I added 1 to limbs, remember? So now I have this. So the median is 5. Okay? I don't know if you changed your data, but I changed mine here in this statement. Okay, so we can do median as well. Okay, now, you studied for homework. You studied, I forced you to look at something that we hadn't covered in class, and that was the standard deviation, right? And you can calculate the standard deviation here as well. So how could we get the standard deviation of limbs? Anybody remember what that is? It's SD, and that's all. That's it. SD of limbs. So before I do that, can anybody just make a very rough guess as to what the standard deviation might be? Or let me put it this way. Is it smaller than 5 or bigger than 5?
Smaller.
Okay, that's good. Smaller than 5. Is it smaller than 4 or less than 4, do you think? Less than 4. Okay, that's all I wanted to get to. So we don't know what it is actually, unless you're really super unbelievably good at calculating things in your head. But a normal person would never be able to do that. So, but we can do that. So what is the standard deviation? 0.754, 0.76 or something like that. Okay, understand that? Now how about if I wanted to put, so oftentimes in statistics, we want to calculate the mean. Again, what was the mean here? What was the mean value? 4.5 for my data. Often in statistics, we want to calculate the mean plus the standard deviation and the mean minus the standard deviation. Well, here, the mean plus is going to be, well, I wonder what would happen. But let's do the mean minus the standard deviation. Put another line there. Does anybody know how to make a different color here? Let's see if they tell us. There's some way to do it, but I don't remember. Graphical parameters. Maybe if I click on this. Let me try that. color for the background. That's BG. There are all these parameters that you can actually play with. The question is, which one is the color? Color for the background. Default plotting color. COL. Maybe that's it. See color specification. Color specification. Color specification, where is that? Where is that color specification? Oh well, I'll let you figure that out. Okay, I'd like to put a different color. Or let me just try something here. Let's try this, see if this works. Try COL. Okay, did it work? Ah. Work. Okay, so let's try that. So you can try this, something like that. You use COL equals blue like that. And that'll give you a color. Okay, so, but anyway, let's go back to what we were trying to do. What were we trying to do? Oh, we were trying to put a line one standard deviation below the mean. I want to take the mean minus the standard deviation and put a line there. So I think they do something like that here. Here. Okay, so we take, they define the mean, or they define something called the mean value, and they define something called the deviation, and then they do this. So where's the definition for the mean for this variable? It's up here, here. So do that. Let's use our original data. So let's use let's use limbs. So take this, but put limbs in there instead. And then call deviation the standard deviation of limbs. Okay, everyone understand what we're trying to do? So I defined a variable for the mean and another variable for the standard deviation. Everyone get that? Here? Mean is mean, and deviation is standard deviation. And now try and put a line, which is the mean value minus the deviation. Try and put a line in your graph and make it blue or some other color. I don't know what colors we can use. Maybe green would work also. But whatever. But try and make a AB line with a horizontal line at the mean value minus the deviation. How do you do that? Something like that might work. Aaron, agree with this approach? So H is the mean value minus the deviation. So again, what was the mean value for my data? It was 4.5. And what was the deviation for my data? 0.75. So the mean minus the standard deviation is 4.5 minus 7.5. So I'm just going to put a line at whatever that is. It's about 3.7 or something like that. And it's going to be a blue line, maybe, if it works. Okay, so here it is. Okay? That makes sense? Okay? So here that was the mean value, and then I subtracted the standard deviation. So in statistics, this is kind of an important picture. That is, you have the mean, and then you find out how one standard deviation away from it. That's kind of important. That tells you like a range for where your data is. You say, oh, the mean is here, one standard deviation lower is here, and one standard deviation bigger is here. And that gives you like a range for where your data is. Right? So I only did the bottom of that. I could do the top, but okay? That makes sense? Okay, we did that. So they did that too, and then we finished chapter 4. Okay, anybody have any questions? So I am recording this, so you can always go back and check the recording. Let's check chapter. Oh, sorry, you guys didn't finish. Hopefully you're supposed to finish chapter 4 on your own, so let's look at chapter 5. Okay, this is new, and this is an important part for statistics. So did I talk about this before, factors? I think I mentioned it before, didn't I? Anyway, this is very important. So let me just explain a little bit about this, and then we'll go back into our statistics book. So factors are really important. Didn't I ask you last week to tell me, I said, I think it was this class, I hope it was this class, I said, if we want to study our APU students, what things would you be interested in knowing about APU students? So we want to do like a statistical analysis of our campus, or some kind of analysis of our campus. Didn't we talk about that last time? Oh, goodness. Okay, I apologize because sometimes I can't remember which class I talked about what. Okay, so let's try that. Suppose I said, I want to do a study about APU students. So what kinds of things could we investigate? Give me some things. What would you like to study, if you could, about APU students? What kinds of things might you want to know? Just give me one example. So I'd like to get one example from each of you. So go ahead, you can talk. Anything.
Places students live.
Places they live. Okay, great. What do you, like, for example, what? Give me one example of that. Like, where do you live, for example? Okay, so like address or something. What did you say? Minami what? Yeah, so like an address or something, or like a location in bed, right? Okay, all right. Let's just call it places living or something like that. Okay, that's one thing. Good. Okay, next person. Anything? Doesn't matter.
the other one?
Okay, countries. Okay, and how about you? Give me one. Anything?
Anything about qualitative
And just, you give me one.
and gender?
Gender, okay, good. Another one, next. Wait, okay. Next person over there. What? Height, okay. Next person.
Circles.
What?
Circles.
I can hear you.
Circles.
Clubs.
Circles.
What?
Curriculum activities?
Curriculum.
Like extra activities?
The circle, circle, right. Good. Circle. Next.
Part-time jobs.
Part-time job. Next.
All the courses that students.
The courses, okay, courses, okay. Okay, that's enough, right? Let's not keep going. So, my only point is, and I was a little bit surprised actually, because my point was that almost everything that you guys said was not quantitative. Now, some people, one person said weight and one person said height, but 99% of this was not even quantitative, right? And when we think of statistics or we think of math, of course we always think quantitative, right? But if you think of what you're interested in, it doesn't look like you're very interested in quantitative stuff. So in other words, if you want to do statistics, you don't want to be limited just to quantitative stuff, right? Because you can see that most people were interested in non-quantitative stuff, right? So these are non-quantitative variables. These are qualitative variables, right? And I asked this some other class, I asked a similar question, and I didn't even get one number. I didn't even get one numerical variable. So generally, people are not that interested in the numerical variables. It doesn't mean they're not interested, but we're certainly interested in non-numerical as well. So the thing is, though, that if I asked you to take, so this would be a variable or a piece of data that we would collect on different students. So we'd have like student 1, student 2, student 3, right? And we'd say, okay, where do you live? What country are you from? What's your gender? What's your weight? What's your height? What's your blah, 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 right? And we'd fill in all of that, right? So here, like the first student place they're living, we'd say Beppu or something, I don't know. And another person was Oita. Another person was Kamigo or something, right? So on, right? Okay, so we'd have we'd have values for that variable, right? Now I want you to do something, and that is I want you to take the mean of that. Right? That doesn't compute, right? You can't understand what I'm talking about, right? Doesn't make any sense, right? You can't take the mean of this, right? The mean is for numbers. So you can't do it, right? So all the statistics that we're learning doesn't even apply to this, right? So hopefully we're going to learn some statistics that do apply to this, right? So, okay, that's the idea, okay? And that's what factors are for. When you take a variable, you take a quantitative variable. In other words, you take a qualitative variable. That's a factor in R. You have to convert it to a factor, and then R will have some good tricks to perform with it. Okay, so you want to turn it into a factor. Factors are for qualitative variables, for non-numeric data. Okay, and then one other word you need to know besides the word factor is R calls these different possible values, the levels of this particular variable, or the levels of this particular factor. Okay, so what are the levels so far for this variable? What are the levels? What are the different values that we have so far? Beppu, Oita, and Kamigawa. Okay, those are called the levels. Okay, the factor is living places or something like that, and the levels of that factor so far are these three. Okay, you understand? We don't usually use the word levels when you have a numeric variable, because usually then there are too many, right? You have, if you say people's weight, that's basically an uncountable number, right? So we don't use the word levels there. But when you talk about a non-numeric variable, you talk about the different levels. That means the different values that it could take. The different values that it could take. Okay? Is that clear? Okay, so basically you want to take a non-numeric data and convert it to a factor first, and then R will treat it nicely. R will have some tricks that it can do on it that it wouldn't do if it didn't know it was a factor. In other words, you could start out with a string, but R won't treat it as a factor. It'll just treat it as a string. So you don't really want to leave it like that. If you're trying to do, some analysis of it, you don't want to treat it as a string, generally speaking. So they do exactly that here. So here, you can take this, and if you can't, I think you should be able to access it, but if you can't because you haven't gotten this far, then you can just watch what I do. So I do that, and I now have created what? Is that a factor yet? No. What is it now? Just a vector of strings, right? A vector of strings. So if I type it out, chess, what will I see? Gold, silver, gem, gold, gems or something, gold, whatever. Like that, right? That's not a factor yet. Okay, I have to do something extra to turn it into a factor so that R will be able to do special tricks with it. Okay, so what I can do is this. Okay, so we use a function called factor, and we put it in there, and we'll assign the result to types. And then types will be a factor. Okay, get it? Now if I type types, it's not going to give me the same printout that it did with chess, as you'll see. Let's see. So if I type types, I get something like that. Okay, so it's different. And that means that R is now treating it as a factor. Okay, now you don't know what good that will do you, but it has some power to it that you couldn't get if you just had it as a string. Okay, and this is what it prints out. So first of all, it's no longer a vector of strings. There are no quotes here. Okay, so it's somehow different. And also it prints out the levels here. Now, what does it tell me the levels are? Gems, gold, and silver. In other words, it just tells you the unique values for the levels, right? It just tells you the values that this variable could be. And so far it can only be those three. Okay, so it just lists them like that when in the levels section there. Okay, does this make sense? That makes sense? Okay. So, and also they tell us in this course that if you do, let's try, I wonder what will happen if I do this. If I do this with limbs, what's going to happen? Let's see. If I type out this, doesn't, okay, first let's just see what it does, and then we'll see what it means. So let me do as integer limbs. I don't even know what it's going to do. Does that work, really? Okay. Now let me do as integer types. And you don't even know what that means, but let's just see what it does. Okay, good. So look at that, that's pretty different. Now as integer is supposed to convert it, whatever you put in there, to integers. So, oh wait, sorry, I did the wrong thing. Sorry about that, that didn't make sense. I didn't know. I meant chests. Let's see if that works. Okay. Okay, sorry about that. Let me repeat that. I made a mistake. I didn't mean to do as integer limbs. I meant as integer chests. So look at what I did, look what I get when I do as integer chests. What do I get? Get this mess, right? It's a big mess. Okay, it's trying to convert chests, which is this vector of these strings, to integers. That doesn't really make sense to do that, right? So it just says, it doesn't know what to do. Okay, it says not available, not available, not available, not available. So it just says, I don't know what to do. Okay? However, of course when I did that on limbs that was different, but I didn't mean to do this one. But types, now what's the relationship between chests and types? Here, right? Chests was the vector of strings, and types was what? A factor, right? And I just tried as integer on chests, it doesn't make any sense. But what about when I do as integer on types? That doesn't, you don't understand that. I didn't explain what's going on there, but it didn't give me NA, right? It didn't give me NA. So the point here is that types is what kind of object again? What kind of object is types? It's a what? A factor, right? It's a factor. The point is that the way that R stores factors is as numbers. Well, that sounds really weird. But what it means is, look at this. 2, 3, 1, 2, 1. What was the actual factor? Gold, silver, gems, gold, gems. Right? So, you see, let's see, here's a 2 and here's a 2, right? Here's gold and here's gold, right? So what it's doing is it's storing gold as the integer 2. Now you'd say, why 2? It's not, it just has to, it might be, it must be random. Okay, or it might be kind of, actually it's, I think it's, it looks at it alphabetically or something. So of these, that's right, it looks at it alphabetically by default. So which is the first, if we listed these alphabetically, what would come first? Gems would, right? You see that? Gems comes first. So gems is 1. Then what comes after gems alphabetically? Gold. So gold is 2, and silver is 3, right? So what it does is it assigns, but the thing is, internally, inside R, when you create a factor, it stores them as numbers, and that's so that it can kind of do things more quickly. It works more quickly when they're numbers than when they are strings. Okay, that's just one small advantage to creating them as factors, but really that's not the important reason to do it as factors. But it's true though, they are stored as numbers. Okay, so that's just the way it works. Internally, as I say, under the hood in R, they're being stored as numbers. And so when you apply the as integer to it, it does show the number. It does show something. It does show numbers. But these numbers are just, as I said, they're just kind of arbitrary numbers. But that's just showing you the way it's stored internally. But that's, as I said, that's not the point of turning it into a factor at all. There are many other points or reasons to do that. Okay? Now let's try these two here, weights and prices, I'll just create them here. No, sorry, I'll just copy them here in case you can't access this. I'll do that. Weights and prices. Okay, so what are weight and prices? What kind of objects are they? What are weights and prices? They're what? They're both vectors, right? And they're both vectors of numbers, right? And do they have the same number of objects? Or same number of elements? How many elements are in weights? 5. How many elements are in prices? 5. Okay, now we're going to explore one more thing, and then we have to go on to our statistics class. I'm going to do this. Weights comma, prices. Now, you don't know what this is going to do, but I can tell you, well, okay, let's just see. Ready? Plot, weights, prices. First of all, what's the first element of weights? 300. What's the first element of prices? 900, right? And these are supposed to be related. In other words, there's some object that maybe these are the chests. Okay, so maybe the first chest weighs 300 pounds and it's worth $9,000. Okay, so these are supposed to be related like that. Okay, now let's see what happens when I do the plot function. Ready? 1, 2, 3, plot. And I get that. What was the smallest weight in this list? 100. And what was the biggest one? 300. So this graph goes from, the x-axis of this graph is what? Weights. And the y-axis is what? Prices. Weights, prices. Okay? And the smallest, this graph goes, the x-axis goes from about 300, from about 100 to 300. Right? That, by the way, is a little bit confusing in R. It doesn't go all the way down to 0 unless you force it to. Okay, so that's, sometimes you don't expect that. Okay, anyway, so where does this, I see a dot here, where does that come from? Where does that come from? What are the coordinates of that dot? The x-coordinate is 100 and the y-coordinate is 12,000. Where does that come from? The third element of the weights vector is what? 100, and the third element of the price vector is 12,000, right? So that's where it comes from. Okay? How about the next dot? What's this one here? 150, comma, 1800, right? Where does that come from? The fifth element of the weights vector is 150, and the fifth element of the price vector is 1800, okay? Everyone understand that? Okay? How about if I wanted to put a average, I wonder if I could do it, yeah. If I wanted to put the mean of the prices as a line in there, how could I do that? If I want to put the mean of the prices in there, how could I do it? Could you do it? Or tell me what to type? AB line what? Horizontal line, right? So what is that? H equals what? Mean of prices, right? That makes sense? Let's see if it works. Oh, maybe I'll do color. So you get that, right? Now you can see the mean prices, and you can see how the prices fluctuate around that mean, right? Everyone see that? So that's why it might be useful to do that. How about, well, okay, we could also put in a standard deviation above and a standard deviation below, right? And then we could see how many of the dots, we would say how many of the dots are within one standard deviation of the mean. In fact, let's try that. How do I do that? I wonder if I can do it this way. I'm not sure if this will work. Let me try it. Okay, let's see if this works. I don't know if it will. Maybe, yeah, it worked. Okay? So, you see what I did? I just said H equals the mean of the prices plus standard deviation of the prices. That makes sense? And then I could do the same thing for minus. Like that. And do you see the graph now? So how many of the dots are outside of that range? How many of the dots are outside of that range? Two. Two out of how many? 2 out of a total of 5, right? Okay? So, actually there's some weird theorems that can tell you the maximum number of dots that could be outside of that range. There's a weird theorem called Chebyshev's theorem. Chebyshev was a Russian mathematician who will he can tell you that you can't have more than a certain percentage outside of that range. And if you go 2 standard deviations, they'll tell you that you can't have more than a certain percentage outside of that range, and so on. So hopefully we'll get to that theorem. But anyway, can you see this data? Okay, so, by the way, what percentage is within 1 standard deviation of the mean? By the way, what do I mean by within 1 standard deviation of the mean? I mean, this is the mean, the blue line, and 1 standard deviation up is here, and 1 standard deviation down is here. What percent are between, are within this range? What's the answer? 3 out of 5, right? Which is what percent? 3 out of 5 is 6 out of 10, right? And 6 out of 10 is what percentage? 60%, right? So 60% of our data, we would say, is within 1 standard deviation of the mean. Okay, understand? Now, okay, everyone understand what we did? Okay, that's important, and we'll be talking in sentences like that as we go forward in statistics. But you can see it's true in this case. I mean, you can see that this is what it is in this case, right? That 60% of the data is within 1 standard deviation of the mean. Okay, anybody have any questions about that? Okay. So for homework, I want you to finish chapter 5 and then go on also. No, I'll talk about this next time. Data frames. Data frames are just another way of storing data. And the thing is that with vectors and matrices we can store data, but the main drawback for vectors and matrices is that all the data has to be of the same type. Right? Remember that? They all have to be numbers, or they can all be strings, or blah, blah, blah. But usually, when we're doing some kind of analysis, we don't have just one type of data, we have many types of data. Okay? So we want to have that flexibility, and then we need something like a data frame to store our data. So we'll come to that next time. Okay, let's go to Wiley Plus. Okay, let's see, should I? All right, let's take 5 minutes, and then I'll unfortunately ask you to log off your computer in 5 minutes. So finish up whatever you might be doing on there, and then I'll ask you to log off, and we'll have the rest of the class. Take a 5-minute break. Come back at 46. Actually, it won't ask you to log off. I will log you off. I can do it from here. Okay, first of all, I saw somebody just now trying to compute the standard deviation, which is great. I'm very glad. But I just realized maybe just tell you something about Excel, and that is you can do that in Excel automatically, right? Maybe you know that. Right, so if you have 1, 2, 3, 4, 5, and you want to calculate the standard deviation of that, you can use what? I think it's maybe it's ST here. There are different ones. The basic one is here. There are slightly different reasons to have slightly different formulas. But then you just do this. And that. Okay. And the computer's working. It will give you the answer. There. Okay. Okay? That's the standard deviation. But anyway, but it's good if you did it by hand once, right? Of course, you don't want to do that in the future, but it's certainly good to have done it once by yourself. Okay, now let's actually go to chapter 3. I guess that's all we have. Let me explain these concepts of the standard deviation and the range. So let's imagine that you work for a company that sells aspirin to hospitals. Okay, so you sell aspirin to hospitals, and you have this factory, and you have this, you need to pour the aspirin into boxes and send them to the hospitals. And let's say each box contains 10,000 aspirin, because hospitals need a lot of aspirin. So you have this conveyor belt here, and it has these boxes, and then it has this, this thing here where the aspirin come in, right? And it drops the aspirin into the boxes. And you work at this company and it's broke. The machine broke. So you have a boss and he says, okay, you got to find a new machine. So you go out and he says, go out and find out the latest machines. Give me a report. So he goes out. So you go out and you say, oh, okay, I found 2 machines. There's machine A and machine B, 2 different companies, And one of them costs $1 million, and one of them costs $200,000. And you say, okay, I went over and I tested this, and I found out, I did a small experiment, and I found that the pattern for machine A was the first box had 9999 aspirin, and the next one had 10,001, and the next one had 9999, the next one had 10,001, and so on. And then I tested the second machine, and it looked like this: 0, 20,000, 0, 20,000, and so on. Okay? No, I'm sorry, you don't tell your boss that, you just go and you test these machines, you find that. And then you go back to your boss and you say, okay, I did a study, and I found the two machines, and I found that the mean for A was what? The mean output for A was what? Was 10,000, right? And then, okay, so 10,000. And the mean output for B was what? 10,000, right? So, and then your boss's phone rings, and he picks it up. He says, "Okay, I have to talk to this other person. Please leave." And so you leave. And then, like 3 weeks later, he calls you into the office, and he starts screaming and yelling. And he's going to fire you because why? Because he said, "Oh, the mean for both of them is 10,000, and the B is only $200,000." So he went out and bought machine B, right? Which is totally a messed up machine, right? Right? So what you did is you summarized the data for him. We say summarized the data for him using the measure called the mean of the data, which is certainly a normal thing to do. But here you can see a deficiency in summarizing data, and especially in this case summarizing it with the mean, right? Of course you were right that the mean of A and the mean of B you reported them correctly, so that wasn't the problem. But the problem is that those measures are not necessarily the whole story, right? Right? There's other parts. And what the mean fails to measure, what the mean fails to measure is the variability of the data, right? It doesn't even touch that notion, right? Here we have 10,000 and 10,000, but they're totally, the variation in the data is completely different for A and B. So, as an analyst, you want to develop some other measure for variability besides just the mean. I mean, the mean doesn't give you any measure of variability. So you want some measure of variability. So the simplest measure would be the range. That's very simple. So the range of A, by the range we mean the highest value in the data set minus the lowest value. So the range, so the highest value is what in A? 10,001, and the smallest value is what? 9999, and the difference between those is 2. So the range is 2. And the range for B is what? Is 20,000. So there, immediately, you've nailed it, right? You've captured the fact that the variation is completely different. Okay? So that's very effective. But the range isn't always enough, good enough. It's certainly the simplest one, because all you need to do is find the highest value and the lowest value. So that's pretty simple to make that calculation once you've found those. But if you take take this data set, suppose you have a different data set A, B. So this one is like 0, 0, 50, 100, 100. And this one is 0, this one is 0, 100, no, I'm sorry. what do I want to say? This one is 0, 50, 50. I forget. Yeah. No. Yeah. Forget what I'm doing now. Sorry. This one, 0, 0. Yeah, 50, sorry. I forget what I'm doing. Okay, so I think that's. Something's wrong. But okay, like that. Okay, so A and B. So what's the range for A? 100. The range for B. Also 100. So according to the range, those are both the same variation. But I tried to make it, if I had made this bigger, it would have looked more clear. But I tried to have like everything in B was not at the ends. It was all basically at the middle data for everything except for the two endpoints. Right? So I could have had a bigger data set, it would have looked more clear. But anyway, the variation for this one is more, we would say, than the variation of this. At least visually it seems to be. But the range doesn't capture that. So therefore we want something else. So what we're going to do, what you could do is make this, calculate the variance. And you studied that. But basically all the variance is it's trying to measure each piece of data, how far is it, how much variation is there for each piece of data. Because the range only looks at two pieces of data, the biggest and the smallest. But with the variance, we look at each piece and how much variation there is. So to say how much variation there is, I have to measure how far is this from something. So I'm going to measure how far is this from the center, and how far is this from the center, and how far is this from the center, and how far is each of them from the center. So what is the center for A? By the center we could mean different things. We could mean the median, but we don't. We mean the mean usually, but we could do it with the median. But we're going to do it with the mean. So then what is the center for A if it's the mean? It's 50, right? So I can say, how far is this from the center? 50 units, right? How far is this from the center? 50 units. How far is this from the center? 0, 0. Right? 50 is 0 from 50. How far is this from the center? 50 units. How far is this from the center? 50. So we have a list. 50 units, 0, 50, 50. Right? Whereas this one's going to be what? 50 units, 0, 0, 0, 50, right? Okay, so that's picking up the difference in the variation, right? Those two lists. Okay? Now, actually, we want to include the signs as well. So this is going to be 0 minus 50 is going to be negative 50. This is going to be 100 minus 50, that's going to be positive 50. So what's that calculation that we're doing? We just did, first of all, we had the values, we call them xi. So we had 0, 0, 50, 100, 100. That's 0, 0, 50, 100, 100. Okay, those are the values. And then what did we just do, the calculations we just did? We did how far is each one of those from the mean, right? And that's, we denote each one of them by x sub I. And then the distance from the mean is what? Minus the mean. That's the symbol for the mean, right? X bar. So the mean we already know that's 50. So this is 0 minus 50. This is 0 minus 50. This is 50 minus 50. This is 100 minus 50. And this is 100 minus 50. So we get minus 50 minus 50, 0, 50, 50. Right? Okay. And then we just want to summarize those, because I don't want to just have a list. I want to have a single number. So I want to summarize these. Now the problem is if I summarize these, what do I get? 50, 50, 0, 50, 50, minus, minus, 0, plus, plus. What am I going to get? I'm going to get 0. And how about if I did it with this list? I get the same thing. Let me just do it over here. What do I have? 0, 50, 50, 50, 100, then xi minus x bar is what? This is minus 50, 0, 0, 0, 50, right? So if I summarize that, what do I get? 0, right? So that doesn't really help, right? Because my goal here is to say that B is more, has more variation than A, and now I get this number 0 for both of them. That doesn't really help, right? But this list helps, right? This list was what? Minus 50, 0, 50, 50, right? That shows me the variation is more here, bigger variations here than here. The list helps, but when I summarize it, I lose that, right? And why did I lose it? Because of the cancellation, right? So what they do instead, kind of a weird thing to do, because what normally you would think to do is just delete the minus sign, delete the signs, and then summarize it. But that's not what they do. Instead, they do this, which also gets rid of the cancellation, right? It also gets rid of the signs. But it seems kind of like a weird way to get rid of the signs, because you're blowing up all those numbers. But that is what they do. So now I get what? For this one I get 2500, 2500, 0, 2500, 2500, and for this one I get what? I get 2500, 0, 0, 0, 2500. Right? So now if I summarize this list, what do I get? I get 5,000. If I summarize this list, what do I get? 10,000. So therefore, this is bigger, so that means this has more variation than this, and this was which one? This was, I think, A, right? Yeah, this was A. So that is called the variance. Well, no, sorry, almost. Then what they do is they divide by 5, or sometimes by 4. By 5 or 4. Anyway, why do they divide by 5? Because we had 5 pieces of data, right? So divide by 5. So here I get 10,000 divided by 5, and here I get 5,000 divided by 5, right? So that's just to bring it a little bit back to scale. Not to bring it back to scale, but anyway, that's 2,000 versus 1,000, right? So that number is bigger than that. Okay, now you will probably still feel a little bit bothered by this calculation because we did that squaring, and so these numbers are huge and don't seem to have anything to do with the original data, right? In terms of the size. And so, what's the next step? Take the square root of these results. So then we take the square root of 2,000, and the square root of 1,000. And that brings them back to somewhere close to the original numbers. Right? The square root of 1,000 is about 30 something? What? 31. And the square root of 2,000 is bigger than that. Right? So that brings them down. 31 is kind of close to the original data set. And that's supposed to be the typical deviation or spread from the center. Now, it's not perfect, right? In terms of what you would intuitively mean by the typical spread, because we did squaring and then adding and then taking the square root. But that's the idea. Okay? So that's what the standard deviation is. So what did we do? First we took xi minus x bar for each I, for each data point, and we squared those, and then we added up those values, right? And then we divided by the number. Sometimes we divide by n minus 1, and you'll see that also. And there's reason for dividing by n minus 1 instead of n. But anyway, that basically you would say you divide by n, not n minus 1. But actually there's some other reason to do n minus 1 as well. Okay, so that's it. That's called the standard deviation. And then you could see that Excel just did it very quickly. But you could also build the formula yourself in Excel easily to do it. Okay, that's the standard deviation. And let's see what else we have. Well, looks like we didn't get too far. What else is in here? What's this about? Range. Oh, percentile. Let's do that. Where's the book? Oh. What does that do, percentile? Oh, these are all due November 6th. Okay, let's see that. Okay, here's the standard deviation, and there's a special way to do it when you have group data, but basically what I just showed you is exactly right, just to make there's easier ways to do it when you have group data. Group data means when you have repeated values, like you might have, well, we had group data actually because we had several 50s, right, or several 100s. So that would be group data. So it's like a shortcut you can do in that case. So you can read that. And then uses of the standard deviation, you should definitely read that. And then measures of position, let's quickly review that. Or quickly go through that. So here's what are called the quartiles. So let me ask you, suppose we had a test and we had 100 students and you were in the 95th percentile. What would that mean? Anybody know what that means? If you were, your grade was the 95th percentile grade. There were 100 students who took the test. What does that mean? Yeah, you did better than 95% of the students, or whatever it is, 94, 95, something like that. Yeah, that's right. Okay, so the percentile score is that. Okay? It means that that score was higher than some percent, if it's the 70th percentile, means that score is higher than 70% of the scores. Okay, how about if you're in the 70th percentile of all weights? Weights at APU, what does that mean? 70th percentile of all the weights. That means you weigh more than 70% of APU students, right? So it doesn't just have to do with grades. It could be with anything, right? Okay? And then we give special names to the 25th percentile and the 75th percentile. So the 25th percentile means what again? That number is higher than 25% of the scores. And the 75th percentile means what? That number is higher than 75% of the scores. But those two percentiles have special names. The 25th percentile is called the first quartile. And the 75th percentile is called the third quartile. And what is the second quartile? That has a special name that you already know. That's the median, right? Isn't that the median? The median is what? The number which is 50%, higher than 50% and lower than 50%, right? So that's the median, so that's the 50th percentile. Okay? Now, one more thing, and that is, we just talked about a measure of spread. In fact, we mentioned two measures of spread. What were they? Range and variance or standard deviation. Two different ones, right? Now we have one more, and that is this distance here, from Q1 to Q3. So that's called, that has a name also. That's called, anyway, I can't find it now, but that's called the inner quartile range. So that's right here. This distance here. So what does that mean? Let's suppose that for all the heights of APU students, what should I say is the 75th percentile heights? Say 172? Let's say 172, maybe that's not right, but let's just make it up. Now what do I mean by that? 75% of the students are less than 172 centimeters. Okay, and let's say the first quartile, the 25th percentile score should be what? 152, or let's say 155. 155, so 25% of the students are less than what? 155. You get it? So what are the two numbers I just said? 155 and what? 172, right? Okay, you understand? So what did we say? 75% of the students are less than 172. And what was the other one? 25% of the students are less than 155. So what's the distance between 172 and 155? 172 and 155 is what? 17, right? Is that right or wrong? 170, 155, 6, yeah, 17, right? So that's called the inner quartile range. So that's the distance from here to here. So the inner quartile range is what? In that example? 17 centimeters, right? 17 centimeters. That's a kind of measure of how spread out the data is, right? So that's another measure of spread, or another measure of deviation. They use the word spread or deviation. Okay? So the inner quartile range. Okay? Okay, that's all. There's one other thing here. Okay, last thing I'll just quickly tell you. Something called the Box and Whisker Plot, which looks like this. Okay, here we have some data. This represents income, people's incomes, maybe in tens of and thousands of dollars. So here we have like some people are earning like close to 105,000. Some people are down at 75. What this box does, the left end of this box is the 25th percentile value, and the right side of this box is the 75th percentile value. So it means that 75% of all the people in this study earn like less than about 100 and something thousand, maybe 105,000, right? And 25% earn less than what? Whatever this number is, maybe $76,000, right? And in between there, this is the inner quartile range, right? So the inner quartile range is about $30,000. So that tells you something about the spread of the income in that society, right? Okay, and then down here we also have these things here, and you can read about this, but basically this value and this value, this is the 25th percentile, also called the lower quartile, called the first quartile, and this is the 75th percentile, that's called the third quartile, and by the way, this line here is the median. Okay, so you can read more about this here. Okay? Maybe that's all. I'll try to upload this video in case you want to review it.